Thank you, everyone. Thank you for those who are still here. My name is Vadim. I work at Atlassian, iOS dev. So, the topic. Two things I think probably the most controversial teammate can bring up with a team of iOS developers. Let's use React Native and let's use RxSwift. So both of them kind of like change everything you're used to. So, and with RxSwift, I see a lot of, and I also experienced a lot of confusion, even when you kind of got the glimpse of what reactive streams are about. How do I use this? How do I where is it applicable? What should I be solving this with RxSwift? So the talk would be showing you where to put everything, what things should be responsible for. So, key concepts we will be looking at. So, reactive streams. This is our foundation. This is what I have to assume you, at least to a certain extent, already know, because it will be based on this. So, quick show of hands who are familiar with reactive streams. Most of you are, which is terrific. For those who are not, imagine an array, imagine there is a get method, but you're not getting immediately something, you'll be getting something during different time periods. That's only the quickest the quickest crash course I can give you. So unidirectional flow, you probably heard of this a lot already because it's a popular idea, and the state reducer. So most of you heard of Redux, Flux, Elm architecture, Cycle.js. They're all in the same basically family, like large family of patterns and architectures. What I'll be showing is not an architecture, is not a library, it's a pattern. You can use it on a small scale and a large scale. You don't need any kind of library to implement this, except for reactive Swift, RxSwift. RxSwift and RxCocoa, actually. The tiny bit of background or theory. So we assume that our view is a function of state, meaning that there is some kind of a state for a view controller, for example, which describes enough of information to render it. So every time we receive a new state, we can render a view. Where we take state from, except for the initial state. So we derive state from the previous state and some kind of incoming action. So there is a function, we take state, take some kind of action, and can produce us our new state. So on the surface, this idea is really, I almost wanted to say trivial, but we're no longer allowed to say that. So it's relatively straightforward. Let's see how to implement this. So we will be doing coding. Yay. Playground. So let's start with the basic concept. Let me show you what we'll be doing. Imagine an app. It's like a recording app. And it's recording basically nothing, only time. You press record, it tells you when it started. You press stop, tells you when it ended, and duration. And it sometimes might fail randomly. Oh, it failed. So start, sometimes it will fail. So we will be modeling this kind of an app. Let's start with our single and the only entity we will have for this app. This would be record. So there is some kind of ID, start date, and potential end date. Now the first thing for the pattern we would need is to define our actions. This will be easy. They'll be not allowed to say this. This is a very simple enum. There is only two potential actions we will have in our system. Toggle, pressing the button, and reload. Reload again the list. The gotcha is that every time we toggle, we go somewhere to the server, and every time we have to reload the state again, because we're changing something on the server. We don't know if it will succeed or not, so we reload it. Let's take a look. Remember the state? The state which describes what we see on the view. This will be our state. There will be a current record, unfinished record, there will be a list of previous records. There will be a potential error. Remember this above the yellow button? This was it. And some kind of indicator for us to say, okay, we should be showing some kind of loading indicator. This is our initial state. Okay, let's start writing. So I will call the class in which the state reducer will reside, interactive. You can call it whatever you want. Ideally, we want to see something like this, mimicking the image I showed you. So we want to receive a stream of actions. And we want to return a stream of states for view to render. This is our ideal world. And for you, as a consumer of this interactor, this is all you want to know. You have some kind of view, you feed the actions to it, you're receiving some states and you render them. Okay. So let's actually try to write this with RxSwift. So the first implementation, the simple one, we can start like this. Return actions. And there is an operator, very convenient operator in RxSwift called scan. It takes some kind of initial state, the one we will start from. And there is also accumulator function. This function will take our previous state and an action from the stream, the receiving stream, and will produce us the potential will produce a state. So I will put this function in state. So and we have to transform it to driver, but let's do it later. So let's see what this magical reduce function might look like. This will be a pure function, meaning no side effects. Take something in, return something out. Initially, we would say, well, let's take action. This is what our theory says. And return a new state. So let's try to implement this. Let's say we received the following action.
Make the name a function.
Correct. Thank you. This is very helpful because I will be writing and talking at the same time. Yeah, not for the man. So let's say we want to handle reload. So the gotcha is we cannot produce the state immediately because remember we have to go to the server, or let's say toggle. So this is asynchronous, and this function, if you look at it, it's inherently synchronous. So we cannot use, if we would be able to use this, we would be able to use any kind of state machine or something like this. But the thing is, we want it to be asynchronous, so we cannot use action directly. So this is where in this large family of algorithms and patterns I described, things start to diverge. Some say, okay, not a problem. You received some action, now indicate in the state that some kind of side effect should take place, like start loading, all true. We won't be doing this. We'll do processing first, and we will have a ready-made state later. So we need to introduce a new concept here. We'll call it mutation. So mutation is a result of processing some kind of action. And there might be more mutations than actions. So imagine this. You're saying toggle. Before you will receive a result of toggle, you first enter the loading state. So you can immediately change the state to indicate that you're loading something, and later on, you will receive the response of the toggle, and you can update the state again. So let me make it a bit faster for us. This will be the full reduce function, which takes mutation. So if we indicate with mutation that we're loading, we indicate that we're loading on a state. If we receive an error, we'll set error. If we receive the new bunch of records, we find the one which is without end date. We assume in this particular case that this is the current record. We update the list of records. So this part is ready. Now we have to update this thing. So we cannot now directly consume actions. We have to handle them. And pay attention, this is where the essence of everything is happening. The rest is like implementation details, how we bind everything. But this is like the core. This small function start makes everything. So we would use operator called flatMap and we'll introduce a new function called handle action. What handle action might look like. Handle action takes a particular action and produces a stream of mutations. Remember, one action, multiple mutations. So this is not happy because we need to return driver. Let's accelerate a bit. We convert to the driver. By driver, if you're not familiar with RxSwift specifics, I'm using signal and driver just because I want to indicate that I'm not expecting any errors. I'm handling them, and when you're communicating with me, you're not sending me errors, you're not receiving me errors in a stream. You receive them as part of the state. Okay, now we have to implement this handle action. We have to call the gateway, etc. But let's say, let's add view and a view controller because we will be using them. View has two signals for us, and you will be simulating its behavior. First, it will send a reload signal, then on the 3-second mark, it will send a toggle signal. We won't be rendering at the moment anything, so we will just print the state and we'll see what we're getting. And the view controller. So view controller is empty stop. It's not doing anything at the moment. The only interesting function here is bind. This is the function inside which we will bind all the signals from the view, invoke this start function, receive a stream of states, and then render this stream of states give the view to render every state from this stream. So how bind might look like? We take every signal from the view. We have only two. We merge them because we need a single stream of actions. So we pass them to the start function. We receive our stream of states, and we drive our view with every state. So on every next state, we will be updating view for state. I hope this is so far so good. Let's go back and see how we're actually doing the asynchronous stuff here. Let's replace this handle action with a bit more sophisticated. So we have two actions to handle, and we will quickly switch here, and depending on the receiving action, we'll call this function or another function. So every function here, every specific function will be returning still a signal stream of mutations. So remember I said we need a sort of a gateway. I call it gateway. Sometimes people call it service or store or repository, whatever you like. And whatever gateway will look like. It will be a thing which will simulate the behavior of the server. It will return us pre-canned answers. This gateway will be really simple. So what it will do, this whole thing will just return error after 1 second. These fetch records will return us pre-canned record answer after 1 second. So let's look at the toggle record. Actually, reload record, because we would need it inside the toggle. Let's go one by one here. So what's the how we handle asynchronous thing? So we start by invoking the fetch records on the gateway. Remember, this returns as a stream, and we know that actually in this case it will be a single. We will expect him to receive a single thing, so it kind of acts like a future. So So it promises us an array of records. We map it to our mutation for the state. So we say we received records, we put it as an associated value to enum, and we also say, importantly, that we want to start with loading. So immediately on the invocation of this function, we immediately produce an event in the stream which will contain a loading mutation for our state. And in case if error happens, we will capture it and will transform as error specific to our state. Toggle function will be really similar. It will toggle on the gateway. It will then ask again for the records. It will also indicate that it's loading initially, and it also will capture errors. So the only thing we're missing is to add gateway here.
You embedded the toggle function within itself.
Good catch. I like it. Thanks a lot. You're saving us time with compilation errors. So, don't do this to use dependency injection, because it's only for demo purposes. There is a whole generation of developers born and raised on Apple tutorials. Remember, Apple tutorials are not the code practice, are not architecture you want to have in your code. Okay, so this is probably enough, if I haven't forgot anything, but we'll quickly realize, to simulate our states. So what happened? We started, remember? We started with, on a view, with reload. So we take our empty state, initial state, and mutate it immediately to indicate that something is loading. Loading is true. After on this 1 second mark, we receive a pre-canned array of records. There is only one record, and it's also unfinished, so it's also the current record. On the 3 second mark, we send toggle. So we also, again indicate that we're loading something, so we're doing something. And because toggle returns pre-canned error, finally we indicate that there is an error in state, but it's no longer loading. Let's make it visual. Let's change this view, which you're still able to understand with a proper view to see how it looks like, but which takes a lot of place. No, we don't want this, we want that. You saw this? We were loading initially. We now loaded. There is one record there. Now I will toggle and it will fail. Yeah. So, thank you. That's not it. We can do it even a tiny bit more entertaining by creating a better gateway, a simulation of gateway. Now there will be a lot of events happening, so it probably will be very hard to notice the change of state, but the app will be almost functional. It randomly will be throwing errors at us, it will be reloading, and we never know whether it's actually toggled something on the server or not, so we have to always reload, see. And here you go, actually, if you look here, you can reason about every state mutation, every change of state through the time, and you can actually test this. So you can write a test, take this interactor, send actions to interactor without any kind of view, receive a finished stream of events with particular time sequences, and every sequence will correspond to a particular state, and make the assertion on this. How it might look like. My peers are sometimes mocking me, show tests or something like this. So I wanted to show quickly how tests might look like. So testing RxSwift is a bit different from testing imperative code, but the team of RxSwift done everything for us to make it simpler. So there is a thing called test scheduler, and it kind of simulates events in time. So we can say this is the whole sequence of states we are expecting. So at 200 mark, we were expecting state with loading true. At 201, we're expecting a state with finished records, and etc., etc. Then we run this whole thing, send at particular times actions there, in this case action, and then simulate the gateway responses at particular times. And we compare it with the result we received from the stream we received from the interactor. In this way we test it and make sure every hour state is the one we're expecting. And moreover, remember the reducer function? It's actually a pure function, so we can also test the reduce function alone. So it will be just a simple, very convenient algorithmic kind of test. You can even test drive it with test-driven tests. So this is it from my side. Thank you for listening. I hope you have questions.
Very interesting talk. So scaling up this idea, you made the interactor as its separate instance. It's a separate like identity.
Subsystem kind of.
Yeah. So if you have multiple view controllers, do you have how do you manage this? How do you usually manage it? Like, do you have different interactors for different view controllers?
So a bit of a disclaimer. So inside this talk, right, there is no answer to this. So it's purposely self-limited, but there are options how you can do this. So I've had previously worked and led a project for a big multi-bank, and we used this idea, and we used a per view controller. So it was kind of like subsystem. So what we, in our practice used, is that if we had something to coordinate between view controllers, we had stores in the system, like store for some kind of entities or even state. And the store might be observed by different interactors. So when one interactor writes something there, the one who cares about the store can listen to it and observe its changes, and then mutate its own state. Some people take it to the extremes, Redux, obviously, say state for the whole system. Maybe it will be your fit, but I described what we do.
Yeah, like the idea that you just mentioned, like it's as if different entities are accessing the same thing, so it's not like one class or like a single path to update a specific resource. So it's like it's hard to manage the store, you know, because multiple interactors are interacting with the same store. Am I making sense? Like in our structure, we usually have one class that accesses the data source in a specific way. It's not like independent entities accessing the same thing.
So what's your problem? Is it like we can simultaneously access something and you don't want this? Can you like elaborate where the problem appears? Because just because I'm accessing the same thing or sending some kind of saving something to the store, to the stream of store, doesn't necessarily indicate for me that there is a problem. So where the problem appears?
Yeah, I'm also trying to figure out. We can take it offline, that's fine.
Sure.
Yeah. Thank you.
Is it the same principle you respond?
Yeah.
Hey, disclaimer, I wrote a Redux library that interacts with reactive frameworks.
Is it
So-
RxSwift?
It's reactive recently.
React? Oh, I've seen this.
Cool.
So you're in the topic campaign?
Yeah. So why is this not a library? I noticed there is a fair bit of boilerplate. Why do you think it shouldn't be a library?
Why it's not a library? the simple answer would be I don't like having many libraries. I find in myself in the camp of people who are saying I don't like many libraries. So I'm in this camp. I try to avoid having many libraries because they sometimes become unmaintained. Sometimes they're doing trivial thing, like one can argue that a llama file is much less relevant nowadays than AF networking it was before. So, like I showed here, I don't necessarily need something additionally to implement this pattern, because often those libraries provide me some kind of like scaffolding, like types. Like this would be your action. You should like conform to this protocol or something like this. I think you can, in many cases, define it for yourself. Libraries might help for those who are unsure. They would like kind of guidance when using this, but I would warn them that if you need guidance when using this particular approach, you might not be even ready for it. So, nothing against libraries, but I wouldn't make a library out of this because you can do it without a library. A quick segue. So this is the scheme of what we actually saw. Sorry for segueing your question to another thing, but I want to show something related to your question. I actually have the source code of app I showed on the GitHub. So it's not a library, but it's a complete source code with everything. So you can go there, check how it's done, replicate or take the only parts you want and do it your way. Would be perfect.
Sorry. Great talk. I really enjoyed it. I actually love the concept of using reactive Swift and also reactive Java, but we're in Kotlin alongside React Native. Just because of the paradigm shift and the context shift is a lot easier going across those different systems. From an architectural standpoint, when it comes to stores, you mentioned that you had multiple stores throughout the application. Do you have a view on global stores? And I've got a second question as well, which you've only talked about reducers. Do you interact with other aspects such as middleware or interceptors or any of the other kind of state-based systems that you can integrate in, so selectors, etc.?
Yeah, so what you mentioned is kind of like reducers. The store is used, in what you mentioned, store is used in very particular meaning of the word. So I was using it in a different word, kind of like repository thing. I was saves entities there usually. What you're asking kind of feels like coming from the perspective of Redux store and having reducers later on.
A variable or so local variables which are effectively a state action, but then global state, which is the store, effectively. But you can have multiple stores, as you've had whenever you're accessing those on the interactive or the per-interactive level. From an architectural standpoint, listening for multiple, or listening to a global store, you have one view controller here and another view controller here. And should this change the is loading, you might want to have gone to another page and seen that something in a bar is actually loading based on the state of the previous object. You don't want to pass across, but store that in global store. But that could also that could either work within the context of two local stores, but then having a middleware dispatched to a global store, or you could just have it persisted in the global store, however you wanted to work. But what I wanted to know is, do you have anything from an architectural standpoint that prevents you or makes you feel that that isn't a good system to or architecture to implement?
So the short answer for you would be we never explored this direction. Moving the system lower in the system, lower in the app. So making kind of like a store where multiple these subsystems will be observing it and it will be detailed enough to indicate that something should be loading. We never explored this direction. So architecturally, we started from another direction. We initially started or we came from the direction of Viper and something similar, actually closer to Uber's Riblets, if anyone familiar with them. So, and in Riblets, they had idea of unidirectional flows on the data layer, in the sense that they have entity stores. So everything you receive from the network, you would put into the entity store. Everyone can observe it, but there was no place for kind of like Redux thing, Redux state of the whole system. So we were based on this ground foundation, and only for the communication between new controller and interactor we used this particular system. I assume in some apps it would be worth exploring this direction. We never explored it.
Last question was Matt.
Yeah, so with this particular approach, is it something you would say use everywhere, anywhere, as much as possible? Or are there particular types of applications, particular problems that you think it's well suited to solving?
I would say definitely worth your time to try and get this out, because this is a technique. So, and you can feel whether it's applicable to you or not. Where I find it's very applicable, it's very applicable if you're implementing some kind of view where you might need redo function. Redo, undo, recovering something from the previous state, so preserving states, finding a particular state, reverting back to it, easy with this. It's also very worthwhile if a lot of things might be happening asynchronously on the screen. So I allow a person, the user, to tap multiple things on the screen. They all have side effects, like going to the server, some of them might fail, and I have to reason holistically about everything I see on the view and decide whether I want to represent this in my state or I want to keep the state I have at the moment. This is where it definitely helps. And I think most of the complex app, with some of their screens, reach this situation. Then you want to have this holistic view of everything on the screen, and you would like to know how certain things affect other things.
Yeah, that's a good approach. You talked about undo. Have you ever tied this into the undo manager in UIKit? No.
Unexplored direction.
Thank you very much, Vadim. Round of applause.